At this stage of the course, we've learned a lot of different reactions. And organic chemists tend to string together all these reactions to make more and more complicated molecules. And so we need to have a method that we use and that we can apply to this problem of how do we take a complex molecule and visualize its pieces so that we can actually make it. If you want a house, you don't just, you can buy a house, but you don't go to Walmart and buy a house. You go to places and you buy lumber and you buy pipes and you buy nails. So we need how does this all come together? And this brings up the idea called retrosynthesis. Oops, I'm on the eraser. Here we go, retrosynthesis. Hard to write when you're using the eraser. Great. So retrosynthesis. Retrosynthesis, if you look at the reactions we've seen so far, we'll say, okay, I'm going to take reagent A and I'll react it with reagent B and then add reagent C and I'll get, D. Okay, so we use these forward arrows to imply that things are happening. Retrosynthesis is a little different. It's a way to look backwards. So here's compound D, and you could say, I think I can make compound D by I can make compound D from C. And how can I make C? Well, maybe I can access C by combining A and B. And so you go from complex to simple. And instead, as you move forward in a reaction, normally you go from simple to complex. So this is a way of retrosynthesis, and these are retrosynthesis arrows, is a way of breaking down something that's highly complex into simpler pieces. And once you get all your pieces are simple enough that you can say, okay, I can either make that easily or I have that chemical on the shelf so that I can then move it through the processes, which is actually what we're showing here, and we can actually make our complex molecule. So we will use this idea of retrosynthetic analysis to do a few synthetic problems and to see how we can break apart a complex molecule into using reactions that we've already seen. So retrosynthetic analysis is the approach, and we'll use this approach to solve synthetic problems.